This shows in general how you would loop through all of the elements in a vector and also how you would loop through all of the elements in a matrix. So if we had a vector variable called vec, our for loop variable, I, would go through all of the values from 1 through the length of the vector, and the action would be to do something with each element in the vector, vec sub I. So when I has a value 1, we're doing something with vec sub 1. When I has a value 2, we're doing something with vec sub 2, and so forth through all of the elements in the vector. Similarly, when we have a matrix, we want to loop through all of the elements in a matrix, and that means a nested loop, looping through the rows and also through the columns. So in MATLAB, we use the size function to get the number of rows and the number of columns in separate variables so that we could then use them. So in this example, our outer for loop is going to be over the rows. So I have a loop variable row that's going to iterate from 1 to r, from 1 to the number of rows. And then the inner loop variable call is going to loop through all of the columns from 1 to c, and then the action is going to be to do something with our matrix sub row comma call. So again, using the loop variables as the indices, first the loop variable over the rows and then the loop variable over the columns. So this is in general in MATLAB how you would loop through the elements of a vector and how you would loop through the elements of a matrix in order to do something with each element. But in MATLAB, you usually don't have to do that. You can vectorize your code. So for example, you could loop through the elements of a vector and subtract 1 from every element. So here's an example of a vector that has 4 elements. Our for loop is going to say I goes from 1 to the length of the vector, and what we're going to do with each element in the vector, vec sub I, is we're going to take that value and subtract 1 from it. So we started with 11, 5, 34, 9. We're going to end up with 10, 4, 33, 8. So subtracting 1 from each element in the vector. But vectorizing that code is so much easier. In MATLAB, all we have to say is vec gets the value of vec minus 1. MATLAB's automatically going to loop through all of the elements in the vector and subtract 1 from each one. So we don't have to write a for loop ourselves in MATLAB to accomplish that. It's automatic. So you can have functions of arrays. You can have functions of both vectors and matrices. So for example, if you have abs, the absolute value function, that will automatically be performed on every element of a vector or matrix. If sine functions, or any function like that will automatically be performed on every element of a vector or matrix. So here's an example of a vector. The vector is -3, 1. So -3, -2, -1, 0, 1. If we take the absolute value of that vector, we get the absolute value of each. So the absolute value of -3 is +3, the absolute value of -2 is +2, the absolute value of -1 is 1, and then 0 and 1. So we get the absolute value of every element in this vector. Again, without a for loop, MATLAB will automatically go through and do that. Here's another example. Here's a matrix. Here's a 2x4 matrix of random integers in the range from 0 to 2. And then I could say sine of the matrix. So I'm going to get, as a result, a matrix with the same dimensions where, again, it's automatically looping through all of the elements and giving me the sign of each element in the matrix. No for loops necessary. So we've seen that the sum function will sum all of the elements in a vector, but what about a matrix? So here's a matrix. It's a 2x3 matrix of random integers, each in the range from 0 to 15. If we say sum of the matrix, notice that what it's doing is it's giving me the sum of each column. So the sum of 1 and 7 is 8, the sum of 15 and 5 is 20, the sum of 9 and 3 is 12. So functions in MATLAB such as sum, prod, min, max, cum sum, etc. all operate on matrices one column at a time. So this is called column-wise. So every one of these functions is going to operate on each column. So sum of the matrix gives me a vector with 3 sums in it, the 3 column sums. So what if I wanted the overall sum of all of the values in the matrix? Well, what I want is the sum of this vector. So I want the sum of the vector that I get when I say sum of mate. So sum of mate is going to give me the overall sum of the matrix. So again, we vectorize code for both vectors and matrices. So here's a set of code here that is going to get the size of a matrix, start a running sum variable at 0, use nested for loops to loop through all of the elements in the matrix. So using the loop variables I and j, first the loop variable over the rows and then the columns. What we're doing is taking each element in the matrix, mate sub I, comma j, and adding it to our running sum. So in other words, getting the overall sum of all of the elements in the matrix, and then once we're done, we print out the value of our running sum. So again, we can do that in MATLAB. We can write the nested for loops to accomplish that in MATLAB. But why would you want to when you can just say sum of the matrix? So the sum is, and then using the sum of the vector of column sums that we're going to get. So again, we can vectorize our code in MATLAB. We don't have to write the nested for loops to go through all of the elements of a matrix. MATLAB will do that for us. So when do I not need to use loops in MATLAB? Loops are still necessary to accomplish some tasks in MATLAB, but loops generally are not necessary when you want to perform an operation or a function on every element of a vector or a matrix. So you can vectorize this code. So if you have a vector vec, a matrix mate, you can say something like vec plus 3. So vec plus 3 is going to take every element in the vector and add 3 to it. Mate times 2 is going to take every element in a matrix and multiply it by 2. Again, you can do operators, you can also do functions. Absolute value of a vec will give you the absolute value of every element in the matrix, or rather in a vector. Sign of mate will give you the sign of every element in the matrix. So this is again vectorizing your code. Now what are the different operations that you can perform on vectors and matrices? Scalar operations are when you take a vector or matrix and use a scalar on it. So if you say something like vec plus 3 or mate times 2, that's just taking, in this case, the scalar 3 and adding to every element in the vector, or the scalar 2 and multiplying by every element in the matrix. Now what we call array operators, those are operators that operate on two vectors or two matrices that have the same dimensions. So this is important. They have to have the same dimensions, because what happens is we go through them element by element, performing the operation on the corresponding elements. So there are a bunch of array operators. The array operators are the plus sign for addition and the minus sign for subtraction. Now the array operators for all operations that are based on multiplication are preceded by a dot. So if you want to multiply two vectors together, again, that have the same dimensions, you say dot star or dot asterisk. If you want to divide, dot slash, either one of the division operators. And if you want to go through element by element, taking one vector or matrix and raising it to the power given by another, you use the dot operator. So again, all of the operations that are based on multiplication are preceded by a dot. Now in MATLAB, if we use just the asterisk, that means matrix multiplication. So that's a very different beast. So all of these are, again, array operators where you have two vectors or two matrices with the same dimensions and you're going through element by element. Now if you wanted to ask the user for input a bunch of times, then that's something that you cannot vectorize. So you would have to do that in a for loop. So let's say we want the user to enter 3 numbers, for example, and we want to put them in a vector. We could have a for loop that repeats 3 times, so our loop variable I goes from 1 to 3, and each time we're putting in a vector v sub I the result that the user enters from the prompt enter a number. So we're prompting the user 3 times to enter a number. Whatever the user enters, we're storing it in a vector v. So for example, this is what it might look like when we execute this code. It says enter a number, I type in 3. And it stores that in v sub 1. So we have our vector v, and we're going to store the number 3 in it. Then the second prompt says enter a number, and I enter a 5. So we're going to put that in v sub 2. So now v is a vector that has 2 elements in it, 1, 2, and we're going to put the 5 in it. And then we prompt the user for a number, and the user enters 7, so now we extend the vector and it has a 7 in it. So once we get out of the loop and we display the vector, we're displaying the 3 numbers in the vector 3, 5, 7. But this is very inefficient, and the way it works is not the way I drew it out here. What actually happens when we create the vectors, when v has just one element in it, the 3. And then we go back through the loop and we say, oh, okay, now we're going to put something in v sub 2. It doesn't just tack on the next location in memory. What has to happen is MATLAB has to say, okay, now we want space in memory for 2 things. So it goes out and finds enough space in memory for 2 values. Now that's going to be called v, and it takes the 3 and it copies it, and then it puts the 5 in the second element. And then when we go back through the loop again and we say, oh, okay, now we want to put a 3rd element in the vector and store a 7 in that, then it's got to go out and find enough location in memory for 3 numbers, copy the 3 and the 5, and then tack on the 7. So this is very inefficient. Every single time you go through the loop, it's got to go out and find another chunk of memory and copy all of the values. So this is not a great idea. So pre-allocating a vector means if you know ahead of time the dimensions of a vector, you start by pre-allocating the vector. So that means setting aside enough memory for all of the elements that you're going to have eventually in the vector. So for example, I could use the zeros function. So if I say v is zeros 1 colon 3, then what that's going to do is that's going to create a row vector that has 3 elements in it, 1, 2, 3, and it's going to put zeros in each element of the vector. Then, when I loop to prompt the user 3 times for a number, instead of extending the vector each time, what I'm going to do is replace the 0 rather in each element with the number that the user enters. So if the user enters 3, we replace the 0 with the 3. If the user enters 11, then we replace the 0 with 11, and so forth. So now, when we do this assignment and we're assigning to v sub I, which is going to be v sub 1 and then v sub 2 and then v sub 3, we're just changing the values in the 3 elements in the vector. We're not extending it. So if you know how big a vector is going to be, or same thing for a matrix, if you know the dimensions of the array, whether it's a vector or a matrix, then you start by pre-allocating it, and then inside of the loop or the loops, you're going to be changing the values rather than extending it.